Good morning Year 11. This is your first revision video on triple chemistry only content. We're going to look first at the Haber process. The Haber process takes nitrogen gas and hydrogen gas and produces ammonia. Ammonia is vital for mankind because we use it as a fertilizer for plants. Plants need ammonia to make proteins, and without the Haber process producing ammonia, we would only be able to produce as much as 2/3 of the food that we do at the moment, which means that lots of the world will go hungry. The Haber process exists in a chemical equilibrium, which means the forward reaction and the backward reaction are happening at the same time. We are going to consider now Le Chatelier's principle. Le Chatelier's principle tells us that the position of this equilibrium, so the amount of products and reactants at any given time, will change to oppose any change in reaction conditions. There's three reaction conditions that we're going to look at. The first one is the effective pressure. The reactants are a total of 4 moles of gas and the products are a total of 2 moles of gas. That means that if you produce more products, you have fewer moles of gas and the pressure will drop. So if we increase the pressure of our reaction, the equilibrium will shift to oppose that, which means the equilibrium will shift towards the products to reduce the pressure back again. So we run the Haber process at higher pressure because this will make the equilibrium move towards the products. We get a higher yield. We can't run the pressure too high though because it's expensive to run very, very high pressures. The second condition is temperature. Now the forward reaction is exothermic, so it increases the temperature. The backwards reaction is endothermic, it decreases the temperature. If we have a high temperature for this reaction, I've drawn an arrow going this way, it will shift the reaction this way because we increase the temperature, the equilibrium will move to favour the endothermic reaction and reduce the temperature back down. Therefore, we actually want to get a high yield to run this at a low temperature. However, the reaction is still run at quite a high temperature, about 450 degrees, because that increases the rate. So although we get less yield, we get a little bit less product, we produce it quicker, so overall it's cheaper industrially. Finally, a catalyst is added to the reaction. The iron catalyst increases the rate of both the forwards and backwards reaction. So it doesn't affect the equilibrium at all, but the iron catalyst is useful again because like the high temperature, it doesn't necessarily do what we want for the yield, but it makes the reaction happen faster so you can produce more product quicker, and that is good for industry and cutting costs. And that is a summary of, firstly, the reactants and products of the Haber process and why we need the product. Secondly, what Le Chatelier's principle says and what that means for the pressure and the temperature and adding a catalyst to the Haber process. If you have any further questions, please don't hesitate to get in contact.